We know what metals are, we know they're super useful, and I think everybody knows that you don't just find like keys laying around out in the environment, but like, how do we actually get metals? The story all begins with rocks because metals don't look anything like the objects I just showed you. They start with these things called ores, and the metals are actually mixed into the rocks, like this malachite and azurite that contains copper. Gold is one of the very few metals that's actually found in its pure native form on Earth. So when you crush up rocks that contain gold and you swirl them around in water, gold is super dense and it falls to the bottom and you can pull it right out. Like these cool gold flecks we found when we went gold panning. The key isn't just finding ores that contain the metals, it's finding really high quality ores that contain a lot of the metals so that they can be profitable as they extract them from the rocks. And wouldn't you know that high quality ore is usually found buried underneath other rock layers that don't have really great quality target metals, so they have to be dug out. So people used to be lowered underground into mines that went for miles and miles, where they would use these crazy hammers and rods to pound holes into the side of the wall, stuff them with dynamite, and then blow the shaft larger and larger and pull all the rest of the rocks out. They had to use all of this framing to help sort of keep the mine from collapsing on top of them, and then they would pull out the rocks and process them. While underground mining certainly still is a way that people get ore out of the ground, the much more popular way now is to use our heavy equipment to dig giant holes into the earth and pile up all of the non-useful rocks on the side. You can see here what that looks like. There's these artificial mountains of mounded dirt that they have pulled out from on top of the useful ore that just sits here. Then it's time to remove the ore from the ground, crush it into a fine powder, and transport it to a place called a refinery. At the refinery, this powder is mixed with water and leaching chemicals to form a chemical reaction that allows the acid mercury or cyanide to remove the metal atoms from the mineral compounds they're trapped in. Finally, the solution is run through the last chemical reaction called electrolysis, where a metal plate is submerged into the solution, and then electricity is run through it, and all of the metal atoms are charged and run from the solution and attach themselves to the metal plate, so now the plate is pure metal. Those plates are then taken off to factories where they're either shaped into useful objects or alloyed more purposefully to create really interesting metal mixtures. As you can see, mining and refining takes a lot of water, so typically mine sites are located next to waterways like lakes, creeks, and rivers, just like this one in Superior, Arizona is located next to Queen Creek. Since only a few out of every 1,000 atoms at the site are actually the metal that we're looking for, there's going to be a lot of waste. The biggest source of waste is the overburden, which is just the rock layers that didn't contain those metals in high concentrations, and they get stacked higher and higher for miles to create this huge scar on the earth where the site is. The really dangerous waste, though, is the tailings from the chemical reactions, where they extracted the gold from that crushed ore, because inside of that ore is other heavy metals that are dangerous to be exposed to wildlife and humans, like arsenic, cadmium, lead, and mercury. The tailings also include the other chemicals from the reactions, like leftover cyanide, leftover mercury, and those aren't great for the environment either. They're typically stored in ponds, which can leak off into the environment if the side of the pond breaks, or if the liners break, they can get down into the aquifers and the groundwater. Here you can see a tailing pond that has that plastic lining, but it's right next to a creek bed. So if something were to happen, the water could just leak right out in there. The actual chemical reactions are going on in a tank up here on the side of the hill, but when they're used up, they go right into those ponds. So obviously people have tried other things like dry stacking all of these tailings, but then all of this nasty stuff can just blow off into the wind. Dumping it directly into the river and the ocean is obviously even worse for the environment than trying to contain it into ponds. There's a slightly less toxic type of waste called slag that's left over from the refining and manufacturing of metal products, and a lot of times it gets incorporated into structures like sidewalks and roadways and building foundations because there's just so much of it that we have to do something so we don't have piles of it sitting around everywhere. There's almost 13,000 mines in the United States, and 287 of them mine metals in a similar way to what I've shown you here today. There's also over 100,000 abandoned mine sites, many of them from over 100 years ago that had even worse ecological practices than I showed you here today. Ultimately, our technological way of life is completely dependent on the metals that come from mines like this. So the only way for us to have a sustainable existence is to figure out how human prosperity isn't at complete odds with ecology.